second one, y equal to 3x plus 4 all raised to the power of 4. The third one, y is equal to 2x plus 5 all raised to the power of 3. And then the last one, y equal to 4x plus 7 all raised to the power of 2. Now this is what you need to do when it comes to differentiation. If the function changes, your way of differentiating that particular function will also change. That means the type of function you see determines the approach you are going to use in differentiating them. You get? Now let's start. Here's the solution to this problem, and for clarity's sake, I will divide it up. Now we have the first one, y equal to x power 5. How can you attempt something like this? Now there's this rule of differentiation that says if you have a function y equal to x power n, the n signifies 5, while the x is the base, that x is the base, n is the index or the exponent. Now if you want to differentiate a function that looks like this, your dy over x, which is your derivative, will be equal to the n, you multiply the base, that will be n times x power n minus 1. N times x power n minus 1. You get? So if n multiplies x, you're going to have nx power n minus 1. Now let's use this approach in solving this. The n is the 5, so our dy over our dx will be equal to 5 times x power 5 minus 1 by this rule. And then our dy over our dx will be equal to 5 times x will give us 5x. And then 5 minus 1 is what? 4. So the derivative of x power 5 is 5x power 4. You get? That's for that one. Now let's proceed further to the second one. We have y equal to 3x plus 4 power 4. Remember what I told you earlier? I said the type of function you see determines the approach you use in solving it, the approach you are going to use in differentiating it. You can see clearly that this function is totally different from this function. This is just y equal to x power 5. Here is bracket e to 3x plus 4 raised to power 4. You can see there's bracket here, there's no bracket here. You can see. So there's differences here. And this type of function is called a composite function or function of a function. You get? Now, why is it called a composite function? A composite function is a type of function that comprises two or more functions. Now, let me show you the two functions. Y is equal to 3x plus 4, all raised to the power of 4. That means the function y depends on the value of x. You get? The function y depends on the value of x, which means if you have not gotten the value of x, you cannot tell us the value of y. So y depends on this. And then for us to have the actual value of x, we have to evaluate this bracket power 4, which means we have y a function of x, a function of 4. You can see. So you have two functions in itself here. So if you want to solve this, we'll say the solution to this. Now we cannot just solve directly. There's a trick of how to solve this, but here I'm just here to break it down. So I will say let a equals 3x plus 4. What I'm doing here is a simple substitution. Let's assume that the letter a is equal to 3x plus 4. So this implies that y is equal to, remember 3x plus 4 has been taken to the a. So it's y equal to a power 4. Everything here is a. So y is equal to a power 4. You get it? Now you differentiate them separately. If you differentiate this, you're going to have the a over the x. And you can differentiate 3x plus 4 using this rule. You're going to have what? 3. Now let's differentiate the next one. And the y over the a. The y the a will give us what? 4a power 3. If you differentiate a power 4 using the same rule, is 4a power 3. Now, completing this, we will now say our dy over our dx is equal to the a dx times dy a. So that the a will cancel out, and then we are still going to have dy over dx. Now, this means that our dy over our dx is equal to the a dx is what? 3 times dy a is what? 4a power 3. 4a power 3, which is the same thing as 3 times 4, 12a power 3. But remember, we said a is equal to what? 3x plus 4. So if a is equal to 3x plus 4, this is the same thing as 12a to the place of a, 3 3x plus 4 all power 3, and that's the derivative of the second function there. Now let's proceed to the third one. The third one we have y equals to 2x plus 5 all power 3. Now the same approach I told you earlier that the function you see, the function you see determines how you're going to differentiate or how you're going to solve it. So you see that this function is almost the same thing with this. It's just the numbers that changes. It's just the numbers. So you see, it's just alike. So it's the same procedure. So we are going to say, here's the solution to this. We say here we use A. You can use any alphabet. It's not compulsory you use A. So let's use U. I can say let U equal to 2x plus 5. And this implies that y is equal to u power 3. Since everything is known to be u, that implies y is equal to u power 3. Then you differentiate it separately. You differentiate this, you're going to have du over the x, which is equal to 2. And then dy over du is equal to 3u squared. Dy over du is equal to 3u squared. This will give us 3u squared. Now, our dy over dx is the same thing as what? The du dx times dy du. Du dx times dy du. Du dx is what? 2 times dy du is what? 3u squared. And then 2 times 3, you're going to have 6u squared. Remember, we said du is equal to what? 2x plus 5. So this will give us 6 in place of u, 2x plus 5 all squared. So we can say our dy over our dx is equal to 6 into 2x plus 5 all squared, and that's the derivative for the third one. Now, if you know you have been following what I've been doing here very well, if you know you have understood what I've done here, just try this one and drop the answer in the comment section. I will see you in my next class. Bye bye.